Hello dear students, in laws of motion chapter we will have to solve a lot of problems involving inclined plane. Okay, sometimes inclined plane will be having smooth surface, sometimes uh, inclined plane will be having rough surface. In the case of a rough surface we have to consider force of friction, but I did not explain you what is friction till now. Okay, after 2-3 sessions I'll explain. Okay, now here what we have done, we have to calculate acceleration of a body on a smooth inclined plane. So what we will do, we will consider a block. Okay, we'll consider a block of mass m on the inclined plane. Say the angle of inclination of this inclined plane is theta. Angle of inclination is theta. We have placed a body of mass m on the inclined plane, and let us suppose that this is a smooth surface. Okay, I have already mentioned here, smooth inclined plane means there is no friction. So what does it mean? Frictionless. So you don't have to consider friction. Okay. Now we will see how this block will move. Basically we know that if it is smooth it will come down, but we will see mathematically how it goes and what will be the acceleration of the mass. Okay, if you consider a mass, like this, and if it is allowed to fall down to the ground, okay, then what is the acceleration of the mass? Okay, F is equal to m into a. This mass will definitely fall down, correct? M into a. What is force acting on the mass? Force acting on the mass is mg, is equal to m into a. So m gets cancelled. So acceleration of the mass is equal to g. Try to understand. In the case of free fall, acceleration of the mass is equal to g. Now what about in this case? Now it is not free fall. Okay, one thing we know is mg is always downwards, correct? Now this is, we are very sure mg is always downwards. Now we have to find out, since the mass is going along the inclined plane, we have to calculate acceleration of the mass along the inclined plane. Okay, so we have to find out what is the force along the inclined plane. This is very simple. Okay, now what I'll do, this angle is theta here. Now I have to resolve this mg. Okay, I have to resolve this mg. One along the inclined plane, one perpendicular to the inclined plane. To the resolution of vector we have to do. So hope you remember how to resolve a vector. If there is a vector a, okay, how to resolve a vector? If this angle is theta, this is a cos theta, correct now? This is a sin theta. If you are not understanding, go back to the previous sessions. Okay, yeah, adjacent side, this is a right angle triangle, adjacent side is equal to hypotenuse into cos theta, correct now? Now we will have to resolve this mg, one perpendicular to the inclined plane and another along the inclined plane. Okay, now here we will construct one right angled triangle. Okay, so we have a right angled triangle here. Okay, now what is this angle? Now this is very important. Okay, now this is very important. Listen, what is this angle? This is 90 degree, correct now? 90 degree. So I have a right angled triangle here. This is 90 degree. What is this angle? This angle is theta. Then what is this angle? This angle should be 90 minus theta, because this is 90, this is theta, this is 90 minus theta. In a triangle, if you add 3 angles, what you should get? You should get 180 degree, correct? Now theta plus 90 degree plus 90 minus theta is equal to 180, because theta and theta gets cancelled, correct now? So therefore this angle should be 90 minus theta. Okay, now this is the vertical. Okay, if this angle is 90 minus theta, then what is this angle? This angle is 90 degree, correct now? This angle is 90 degree. Am I correct? Yeah, 90 degree. out of that, this is 90 minus theta. Total is 90, correct na? Then what is this? This is theta. Yeah? Correct na? The total angle is 90 degree. See, this is the perpendicular. This is 90 degree. This is 90 minus theta. So therefore this should be theta. So that 90 minus theta plus theta should be equal to 90 degree. Yeah. If this is theta, then this angle is also equal to theta. Correct na? Yeah. Now, in this right angle triangle, you have to observe. I'll take one more color. In this right angle triangle, okay, this is 90 degree here. This is hypotenuse, MG is hypotenuse. Correct na? This is adjacent side. Correct na? For this theta, this is opposite side. This is adjacent side. So adjacent side will be therefore mg cos theta. Adjacent side equal to hypotenuse into cos theta. Okay. What is this? This is opposite side. This should be mg sin theta, or this is equal to this. What is this? Mg sin theta. So we have resolved this mg into two components, one along the vertical, one along the horizontal. Now, very important step. What mg cos theta is doing? Mg cos theta is trying to pull the mass in this direction. Whether the mass is coming down? No. Then what does it mean? Mg cos theta is not responsible for the motion. Mg cos theta is not responsible for the acceleration of the mass. Then who is responsible for acceleration? Who is pulling the mass along the inclined plane? Mg sin theta. Mg sin theta is responsible for the acceleration of mass, or F is equal to ma. I have written. Mm gets cancelled. What is acceleration? Acceleration equal to g sin theta. Acceleration of a block moving along inclined plane is equal to g sin theta. Hope you can understand. Or listen once again. Okay? Once again. If this angle is theta, this is a right angle triangle, this is 90 degree. So 90 plus theta plus 90 minus theta should be 180. So therefore this angle is 90 minus theta. We have drawn a normal here, perpendicular. Therefore this angle is 90 degree. If this is 90 degree, this is 90 minus theta. This should be theta. Okay, I have got a right angle triangle here. This is hypotenuse. Mg is hypotenuse. For this theta, this is adjacent side. So therefore this is mg cos theta. This is opposite side. This is mg sin theta. Or therefore this is mg sin theta. Correct na? Hope you can imagine one more right angle triangle here. Okay, then yeah, then what we have written, this mg cos theta, due to this mg cos theta, mass is not moving in this direction. So mg cos theta is not responsible for the motion. Mg sin theta alone is responsible for the acceleration of the mass. So mm gets cancelled. Acceleration of a block on a smooth inclined plane is given by g sin theta. Okay, if theta equal to 90 degree, what happens? If theta equal to 90 degree, then the mass will be under free fall. Correct now? What is sin 90? Sin 90 is 1, A is equal to G. Then you got the similar situation which I have written here. Correct now? Hope you understood this. This is a very, very simple topic that I have done. But you will have to solve many problems based on inclined plane in laws of motion chapter. That is why understanding the resolution of mg is very, very important. Okay. Now, I'll give you a small problem. You do this. Okay, you do this. You have to do this. Okay, answers in the comment section. A constant retarding force of 50 Newton is applied to a body of mass 20 kg. Okay, F is 50 Newton. Mass is 20 kg. Moving initially with a speed of 15 meter per second. Moving initially with a speed of 15 meter per second. U is given. How long does the body take to stop? Means you are asked to find out time. You are asked to find out time. Okay, force is given, mass is given. Okay, body take to stop. How long does the body take to start? Final velocity is 0. Okay, so you have to find out time. You have to find out time. What is given? Initial velocity is given, final velocity is given, acceleration is not given. So you can't use v is equal to u plus cat. But they have given the force. They have given the force and mass. They have given the force and mass. Okay, what is the relation between force and mass? What is the relation between force and mass? F is equal to m into a. Using that relation, you calculate acceleration. Then you come here, you got the acceleration. Use the equation v is equal to u plus at. Okay, you do this, you solve the problem. Okay, fast. Hope you understood the calculation of acceleration of a mass on inclined plane. Okay, thank you very much.